The next thing I want to discuss is how do you join two different inequalities and what are the different ways we can do it. Specifically, they're what we call the and the or logical combination. And so I wanted to just look at an example between the two inequalities we were just working on a few examples ago and see the different ways we could bring them together. So let's say I was examining the set of numbers 5 from 5 to infinity, all numbers larger than 5. Let's say I wanted to create a compound inequality which had both those numbers but also the numbers from the second answer over here, x is less than -3, and join them together into one thing. We often refer to that as a union of two sets, way of joining them, which is often described by the logical separator or. So first of all, I'll go ahead and write this as a compound inequality, how we typically write it. X is greater than or equal to 5, or x is less than -3. And I'll talk more about or and why we use that in just a second. But basically what this is saying is, so as an or operation, what does the logical or operation mean? Basically, if I'm reading this compound inequality, what it's saying is x is greater than or equal to 5, or x could be less than -3. So it's a way of bringing them together into saying, well, it could be in either this or in this, which is a way of saying it's in both sets. It can be in both. Now, it's confusing because a lot of times in English, and is a way of saying I'm trying to do this and this, but and actually does not mean that because and when we do an example of and, I'll kind of explain why. And just as a warning, it's really easy to mix these two things up. And so it's not an end, at the end of the world if you do get them mixed up, but I'm trying to emphasize what the difference is in this video. And so basically how I would draw this on a number line is now I've joined two inequalities saying that x is greater than or equal to 5, or x is less than -3. And basically, if I'm thinking of each as a separate interval, I'm just going to be pasting those two sets together, joining them together into one new set, and that's what the or does. And notice that if I'm trying to write this in interval notation, it's two completely separate intervals of numbers, right? They have no overlap, there's nothing in common. So in this case, there is no you can't write it using a singular interval because it's two disjoint intervals of numbers. And so the only way that I can write that is, well, from -infinity to -3, and 5, well, notice how I said and, but I didn't mean and. It's a very easy thing because that's the English word for this and this. But basically, we often use what's called the union symbol because that's another way of writing joining them. So this is mathematical union, which is a set symbol meaning equivalent to the logical statement or, which is a set symbol that joins them into a larger singular set. So if I was writing it in in interval notation, this would be how I would write multiple different intervals together. Basically, I'm going to write an interval, then u, and this is not a normal u, it's actually called a cup as a symbol. It's like a bigger, it's not really a u, but it's sort of like a u. And it's easier to remember what union means because it looks kind of like a u. And then basically I write my second set. And you can join as many sets as you want by saying this, union this, union this, union this. Excuse me. And it specifically, when there is no overlap, you just write it exactly like that. But in a different case, if there were some overlap, it would change the way we'd write it. And we'll do one more example at the end. Now, the other thing that I was talking about is the secondary set operation, which is called an intersection, which we often use the word and to describe separately. So I want to describe, well, what does and mean and how would this differentiate the problem from above? So if I was to write x is greater than 5, greater than or equal to 5, and x is less than -3, what this means is it has to satisfy both this and this simultaneously to be in my answer. Whereas this said it could be in either this or this to be in my answer, which is why both sets were totally fine answers. But if I think about this, there actually is no way for a number to be both greater than 5 and less than -3 because those sets are different, right? And so where I describe the union as often as a joining operation, the and, which is often called the intersection, is actually an overlap. It's like, where do these sets overlap? And if I were to look at these like on top of each other, so if I was to draw them, usually the intersection, and technically I could write it in the same way where I would have all the numbers from -3 from -infinity to -3 intersection with the numbers from 5 to infinity, which is just a way of the direct translation from the compound inequality notation into interval notation, which is the intersection symbol is what is it's actually the same symbol. It's the cup, but it's upside down. And again, that means, well, what is in both? What is the overlap? And in this case, since there is no overlap, what we'd say is often, well, this is actually equal to no solution. And because as I said, there's no way to have a number be both less than -3 and -5. There is no overlap here, which is why the answer here is there's no solution. And you know, if I draw those sets separately, so this is what I recommend when you're trying to draw them. When you're trying to draw or union, you can just draw both of the sets on top of each other on the number line. But when I'm trying to draw intersection, I would not do that. I would draw them as two separate number lines. X is greater than 5. Whoops, sorry, this was supposed to be a bracket, wasn't it? X is greater than or equal to 5, which would be like that. And on the second one, I would try to keep 0 in the same place on both number lines. We have all numbers less than -3. Be like that. I mean, and I already had these drawn out, but it's helpful to stack them up with alignment to each other. And the intersection is, if I'm looking at it, between these two sets, where are they both shaded? And in this case, there is no overlap because the first set, or I guess this first one, x is greater than or equal to 5, had all the numbers over here. X is less than -3 all over here, but neither one of them had anything in common. So intersection is what is in common. There is nothing in common. End of story. So in the next video, we'll look at a slightly different example because it will change depending on whether the sets have anything in common. When they don't have anything in common, it's exactly like this. But if they do have some overlap, it's still the symbols still mean everything the same, but the answers look a little different.